Now we discuss about the in previous class we discussed about the three derivations and one simple experiment. In this experiment, what we have proved 2s by t square is equal to constant. So constant is k, I will write. Instead of k, to write as acceleration a also. Now how to get this acceleration means to observe the formula s is equal to ut plus half a t square. In that u is equal to 0, substitute there. What do you get? S is equal to 0 into t plus half a t square, or otherwise s is equal to half a t square. So to make a as a subject, send to this side first. What do you get? 2s is equal to a t square. Now t square also send to this side. What do you get? 2s by t square is equal to a. This we have to prove. But instead of that, in previous experiment we wrote that as k. K we can indicate that. But actually it is an acceleration. Okay. That means acceleration is inversely proportional to the time. If time decreases, what happens? Acceleration increases, inversely proportional. One increases, another one will be decreases. Time decreases, acceleration increases. Time increases, acceleration decreases, inversely proportional. This experiment I had to prove by simple demonstration, but actually this all belongs to laws of simple pendulum will be there. Laws of pendulum or simple pendulum. Laws of simple pendulum. What is laws of simple pendulum state? Three laws will be there. First law, second law, and third law. So there are three laws of pendulums are there. First law is said to be the length of the simple pendulum does not be changes. For saying these two laws, length will be constant. Length will be constant. So first one is said to its amplitude must be constant. Amplitude is constant in this first law. So amplitude means maximum displacement is said to be the amplitude. So length does not depends upon its amplitude. One thing. Second law said that it does not depends upon the size, shape of the mass of the bob. So whatever the bob to be considered, simple pendulum means this arrangement we call as a simple pendulum. So this size, shape or mass, whatever will be there, it does not influences the length. Okay, this is the second law. And third law is said that length is directly proportional to the square of the time. So length is directly proportional to the square of the time. L proportional to t square, or otherwise L by t square is equal to constant. But actually in higher discussions I had to prove this one. But instead of that, simple demonstration here only it's an acceleration will be given that we had to discuss in previous class. Now we have to discuss some problems in this chapter. So in this chapter we can discuss about the few examples or otherwise few problems based on this textual questions we had to observe it. So first we consider that here. So some problems we have to consider by basing this four applications. What are the four applications? V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, and sn is equal to un plus a into half n by 2. That we can relate. So here I consider the problems. In these problems I consider the applications. V is equal to u plus at, one application. Second one, s is equal to ut plus half at square, second application. Third application, v square minus u square is equal to 2as. And fourth one to consider, Sn is equal to u plus a into n minus 1 by 2. So these applications we had to consider and we had to prove some problems. So here in first problem we had to see that what is the speed of a body moving with uniform acceleration at the midpoint of 2 points on a straight line where the speeds are u and v respectively. So here we have to consider that what is the speed of the body. Here question to be considered. First question, what is the speed of the body? What is the speed of the body? What is the speed of the body? Speed of the body moving with uniform, moving with an uniform acceleration. Uniform acceleration at the midpoint of on a straight line. Midpoint on a straight line. ST line means straight line, where the speeds are u and v. U is initial velocity, v is final velocity. For this we can verify the answer. Now in this case we have to consider an object O will be considered. It will be moves with velocity u. So object is O, lies at one point. We consider a straight line. This object will be moves. So here to consider object O will be lies. It is an object O. Consider this the object O. It is an object O. Starts with initial velocity u. It starts from initial velocity u and reaches this point with velocity v. So it reaches this velocity with v. So if velocity v comes to reach, final velocity will be taken as v. Now we have to calculate velocity at midpoint. So this is the midpoint. At this midpoint, this is the midpoint, and this considered as the midpoint. At this, what is its velocity? So v0 to be considered. This v0 value will be how much? That you have to calculate it. Now here, to consider total distance covered will be taken as S1. Now from this point, from midpoint, distance will be considered as to be taken as S2. That is taken as S2. Now A is the constant acceleration and S is the distance between the 2 points. Now we have to consider here. So from that we have to observe A is constant acceleration. That means let A be the constant acceleration and S distance between the 2 points. S is considered as distance between the 2 points. What equation we have to get? So in solution to consider let A be the constant acceleration and S be the distance between the 2 points. Then what application we have to consider? V square minus U square is equal to 2AS we have to consider for this application. Initial velocity will be U, final velocity will be A, acceleration is A, distance will be S. Then V square minus U square is equal to 2AS to be considered. Here this total distance considered S, not S1, S to be considered, and this one to be taken as this one to be considered as S1. This one to be taken as S1. Now let V0 be the velocity at the midpoint. So then its velocity will be half, exactly half will be there. No? That means S1 equal to S by 2 be considered. So distance between starting and ending point, let V0 be the velocity of the body at midpoint. So let V0 be the velocity velocity of the body at midpoint you have to consider, and distance to be considered as half of the distance it will be covered. Midpoint means, so the distance to be considered as the distance between starting point to midpoint will be the distance between the starting point to midpoint. So that is taken as S1, that is equal to S by 2. S by 2, half of the distance it will be covered. S by 2 we consider. Now I apply these values in the equation. V square minus U square is equal to I have to consider 2a s by 2, 2a into s by 2. So 2 gets cancelled. Then what it remains here? So 2 gets cancelled. After cancellation, what do you get? V square minus U square is equal to as. That is equation number 2 to be considered. Now substitute 1 into, so what value you have to substitute? Vs by 2, substitute 1, v square minus u square is equal to 2as. So v naught square minus u naught square is equal to v square minus u square by 2. So here to wait some time. We consider as, so take that value that side, okay. So 2as we have to get in this equation. V square minus u square is equal to 2as, v naught square minus u square to as. So v square minus u square is equal to 2as. Here we have to substitute. So 2as by 2. So here we have to consider this will be due to cancellation. We have to keep like that only. 2a into 2, that will be equation number 2. Now in this we have to consider v square minus u square is equal to 2as. So instead of as here in this equation to observe, so to make as as a subject, what do you get? This 2 comes here, what do you get? So observe here, cancel it here. So here we have to cancel it, what do you get? 2as have to remain here. Here 2as remain, that means v square minus u square is equal to as will be remain. So this as value to be taken as, this value of as will be taken as here. In this, take 2 this side, what do you get? V square minus u square by 2 is equal to as you get. So let it be this one taken as equation number 1. V square minus u square by 2 is equal to as. Now what is the value of as here? V square minus u square by 2. That you have to substitute. So substitute 1 into, then what do you get? V naught square minus u square is equal to v square minus u square by 2. Okay. Understand? Now send this to that side. What do you get? V naught square is equal to v square minus u square by 2. Minus comes here, plus u square. Now that is equal to, so here I will write, take LCM. So that is equal to, LCM will be 2. What do you get? V square, here 1 to be considered. So second fraction it is v square plus 2u square. Yes. Here the LCM will be there. 1 into 2, 2. So then 2 into u square, 2u square. Then what do you get here? V square minus u square. plus into minus minus, plus value will be greater. So that's why v square plus u square by 2. What is that value? V naught square is equal to v naught square is equal to v square plus u square by 2. Then v naught is equal to square root of v square plus u square by 2. That's the distance. Numerical values are not given. That's why we have to prove it. At midpoint velocity means we have to calculate that value. Final velocity square plus initial velocity square by 2, and to make square root, then we get that answer. Understand? Once again I repeat this problem. See, the distance we have to calculate the midpoint velocity to be calculated the formula. For calculating that, first we have to consider acceleration must be constant. The distance traveled by the body to consider as s, and its initial velocity u, final velocity v. From there we get v square minus u square is equal to 2as. Okay, v square minus u square is equal to 2as. In this to make as to subject here, observe as to make a subject, 2 comes here, multiplication 1 comes to division. So v square minus u square by 2 is equal to as. So consider like that. Okay. Now what happens? V naught be the velocity at the distance. So instead of v, we can consider v naught. Now distance between that starting point to midpoint we will consider as s by 2. S by 2 will be taken. Now what do you get? V naught square minus, that means v square means v naught square minus u square is equal to 2a. S will be s by 2. 2 gets cancelled. What do you get? V naught square minus v square is equal to as. What is the value of as in the first equation? V square by 2 will be there. That value I have to substitute here. That value I have to substitute here. And we get v naught square minus u square is equal to v square minus u square by 2. Then v naught square is equal to send this u that side. It becomes minus goes there plus. So u square by 1. Now take LCM for this 2. So 2 into 1 means 2 ones are 2. So 1 into v square minus u square means v square minus u square. 1 into 2, 2 into u square, 2u square. So plus 2u square minus u square. Then you get u square plus u square. So v square plus u square by 2. So v naught square is equal to v square plus u square by 2. Then v naught is equal to square root of v square plus u square by 2. Okay.